You can see here, to calculate the best route, the logic is as follows. Analyze the LSDB to find all the possible routes to each reach that subnet. First, I'll find out through what are all the network paths I can go to that particular network. Then, for each possible route, add the OSPF interface cost for all the outgoing interfaces in that route. Cumulative cost. Okay, if I want to go to him, what is my cost? And from there to reach next stop, what is the cost? Add it. From there to next stop, what is the cost? Add it. Like this, you have to make it cumulative cost. And pick the route with the lowest total cost. Clear? And cost is derived from the egress interface bandwidth. And remember, which interface bandwidth will you consider for calculating the metric? Obviously, the interface on which you have received the update, similar to EIGR. I have received, see, if on R5 I am having 3 interfaces. Which interface bandwidth will I include to calculate the metric for that network? Obviously, on which I have received the update. And OSPF cost for each interface can be found show IP OSPF interface command. If you see on our topology, on R1, interface loopback 1. What is my cost? It is 1. E0/0. It is an Ethernet link. My cost is 10. Here. And for Sierra interface, it will be 64. Let me do one thing. Here. I have enabled it, and now if you see 1/2, what is my cost? 64. Clear? Right. Then I'm having 3 neighbors. 1.1.1.3, 2 are same. Why? Because I'm forming the neighborship, one with 21.1 and the other is with through 12 network. Clear? Here, see here. One dot 1.1.3. (21) network. My cost is 64. And through 12 network, my cost is 10. Here. And if you can see here my cost is 11. Why? Because for R1 to reach 1.1.1.1 cost is 1. Clear? And this 1.1.1.1 I am receiving from two routes, from two ways. One is through 21 network and the other is through 12 network. But 12 network I have cost is 10 and through 21 network I am having cost 64. Clear? So that is why out of these two, which one is the best? Obviously the 12 network. It is cost 10, 10 plus 1, 11. And if I make this interface shut down now, interface is 0 by 0 shut for 2 seconds. See how it will be. Down. $65. For R1 it is 1.1.1.1 reach cost is 1. But if I want to reach that particular router, being it is a serial link, my cost is 64. And 64 plus 1, 65. How am I telling it as 64? 1 by 2. What is my cost? 64. Here. And immediately neighborship will be formed, and again it will be reverting back onto that particular 12 network. Okay, so intra area, that is the case. How I told you, in the same area it will be calculating. See, to calculate the best route to each subnet, a router analyzes the LSDB and does the following thing. How does it do? Finds all the subnets inside that area, and based on that stub interfaces listed in the type 1 LSS and based on type 2 LSS networks, it will find out if I want to reach that network, where all can I go through, okay, and what are those interfaces cost I will be adding them, and runs SPF to find all the possible paths in that area topology, and then calculate the OSPF interface cost for all the outgoing interfaces in each route, and then pick the lowest total cost. Clear? But there will be a change in inter area. It is not such a big change, but a little difference. How? Yeah. He is superior. He is R1. Here. 2, 3, 4, 5. Clear? in this topology, let us think here we are having some network 4.4.4.4. R1 will have two databases, one database towards area 1 and one database towards area 0. Clear? So basic thing he say he got one type 1 and type 2 LSS. Clear? And at last he found out that for 4.4.4.4 my cost here it is 1 1 1, and for router 1 it is cost is 1. Now R1 what he does on R1 4.4.4.4 my cost is 4. 1 plus 1 plus 1 3 plus 1 4. Okay, he cannot give type 1 and type 2 LSS into area 0 of area 1, so he will generate in type 3 LSA. And in this already we have seen in this there will be no detailed information, but he will give a brief information that if you guys want to go to 4.4.4.4 reach me via this interface, let us think that as 10.0.0.10. Clear? Cost will be 4. You will tell that in this area if you want to go to 4.4.4.4 via me cost is 4. Now these routers R5, R6, R7 they will have to calculate till R4 till R1 it is 4, and if I want to reach that 4.4.4.4 what is my cost on these interfaces? He will calculate, yes, this cost it is 1 on me, but on R5 to reach R1 cost is 64. So my overall cost is 4, which type 3 LSA has given, plus 64 R5 in order to reach R1, plus my own cost to reach R5. 65 plus 4, 69. My cost is 69. And R7, my cost to reach R5 64. Obviously I have no path, I have to follow the R5. So my cost to reach is 64, plus for R5 to reach R1 it is again 64, plus R1 to that it is 4. 132. Okay, there is no way much big difference, but in inter area the calculation is completely dependent on the type 3 LSA. And remember, type 3 LSA will always give the cost of that ABR to reach that particular network. Clear? He will not change any cost, he will just include his own cost to reach that particular network. And inter area routers, another area routers, they have to calculate their cost in type 3 LSA plus their cost to reach the ABR. Clear? That's it. And this all explanation does the same thing. So for metric calculation, the cost of inter area can be calculated just like inter area routes. How? From router's perspective, it is not that simple, best because inter area routes that are known by type 3 LSA do not provide detailed topology information. Okay, so what do they do? Type 3 LSA lists subnet number, mask, and cost to reach that particular subnet from the ABR's perspective. And now what routers has to do in one area, calculate the cost if inter area route as follows. First, they will calculate the intra area cost to the router ABR, and then cost listed in the LSA. Add that cost listed in the type 3 LSA, and the cost value in the type 3 LSA represents the cost of ABR to the destination subnet. Clear? And now we'll see a metric tuning. How can we change the metric? Clear? Let me see. Now on R1, I don't think we are not receiving any network of R3. Why? Because it's completely in another area. So let me make this guy R2 as an ABR. How will I do it? And as soon as I made it, R1 will have all the database. He's having 3.3.3.3, right? Yeah. On R2, database router 3.3.3.3. He is giving me network 3.3.3.3, and he's telling me the cost as 1. Clear? But what is my own cost? For R3 it is 1. But if I want to reach R3, my cost is again 1. Oh, sorry, 10. My cost is 11. How? Interface is 0/1. For R3 it is 1 plus my cost to reach R3 is 10. 10 plus 1, 11. My cost is 11. Clear? Now our ABR will give this information to R1 OSPF summary from his router ID is 2.2.2.2. Yes, he is telling me about 3.3.3.3. In order to reach, where should I go? I have to go to 2.2.2.2. What is the cost is he giving? 11, right? Then type 3 LS I have got my cost to reach him as 11. Sorry, ABR's cost is 11. But what is my own cost? My cost is 10. My cost to reach ABR is 10 and ABR's cost to reach him is 11. Overall, my complete cost is 21. .3.3.3.3 cost is 21. Clear? This is how metric calculation will be done in interarray. Done? Priority of route selection. If our router is receiving an inter-area update and an intra-area update, inter-area update and external update for the same network, which one will it prefer? Always it will prefer intra-area, okay, which means that same area update. And then it will go for inter-area and then it will prefer external. Here, for a network, see like this. Let me take a connectivity like this. Here on this is the topology, right? And we are having a single network 8.8.8.8. Here on Y and even on R3. Now my R2 will be receiving three updates, three LSAs, one from R3, which is a type 1 LSA for 8.8.8.8. One from external. Let us think this is in EIGRP. And our router X has redistributed that network into this thing. Then it will receive from our router X an external update. Obviously, that is type 5 LSA. And R6 also has it. So ABR will redistribute that, type 3 LSA, it will generate it towards the area 1. Now it is receiving the same network as a type 1 LSA, as a type 3 LSA and type 5 LSA. Who will select it? Obviously, first it will go for type 1 LSA. If this type 1 LSA is down, I mean this network is down here, then it will go for inter area type 3 LSA. And if this is down, then it will go for external LSA, that is type 1. This is the hierarchy of selection. And you can see here, when there is a change in type 1 and type 2 LSA, a router must run SPF algorithm to converge the network to find out the new best paths. Obviously, if a type 1 LSA says that that network is down, again it has to break all the SPF, and again it has to reconstruct it, SPF tree. And a change in type 3 LSA does not drive the recalculation of the SPF algorithm, because type 3 LSA do not actually describe any topology change. If a type 3 LSA says that network is not reachable, I will not take that risk. Why? Because I don't have any detailed information in that type 3 LSA. It just says about a network. Clear? I'll just break that down. That's not a big deal. And to see the number of SPF runs and the elapsed time since the last SPF run using the show IP OSPF. How can we check it? How many times the SPF, at what time the last SPF is run? SPF algorithm till now it has run 12 times. And when is the last time it was done? 9 hours 34 minutes. Yeah. So actually here we don't have any NTP server which says router an exact time here, but in real time scenario this will be the scenario. You'll be having an exact time according to your router's timer. Here. And what is my time? Okay. Yeah, it is 6 hours 7 minutes. but the command will be this thing. Clear? Here it is not showing the exact. It is saying that it has been executed 11 seconds ago. Sorry, it is not the time. It is telling about the how many minutes it's been SPF algorithm run. It's saying 40 minutes ago, 11 seconds ago. Clear? And how many times? 13 times. Clear? But if I change an LSA change here, interface L1 shut. This is in this area. Okay. When this is changed, type 2 LS ABR will generate a type 3 LSA telling that this network is down. No 3 network. Oh, this means SPF will be running. Okay, so SPF algorithm will run for even for type 3 LSA also. Clear? When was for last time we have checked, it is 14 times. It was 13 times here. In the mid, did anything happen? Maybe. Clear? So that is the thing. And how can you check it with the show IP OSPF command? This will show you how many times the SPF algorithm has been run. And if you want to do metric tuning, actually you can do it in 3 ways. And why do we do metric tuning? In order to path manipulate. Clear? In order to path manipulate. That's the major reason. And how many ways can we do OSPF cost or metric tuning? In 3 ways. One, we can change the reference bandwidth, or else by setting the bandwidth of the interface, or directly changing the cost of our interface. Clear? And if you want to change the reference bandwidth, OSPF calculates OSPF cost for an interface based on the following formula. And what is the formula? Obviously, as I told you, this reference bandwidth by interface bandwidth. The default reference bandwidth is 100 Mbps. And how can you change this? Reference bandwidth by auto cost reference bandwidth command. Clear? Let me go here. Auto cost reference bandwidth. Let me make it as 10,000. I roughly made it 10, 3, 3, 8. Obviously, it is 8, 9. Ooh. 1,000. OSPF reference bandwidth is changed. Please ensure that reference bandwidth is consistent across all routers. This is a change. When you are changing the reference bandwidth, you have to make sure that reference bandwidth is same on all the routers. Why? Because your router will be thinking that if you have changed reference bandwidth, okay, all the cost for this router will be changed, right? And this reference bandwidth will never be carried in any of the messages. So the other routers will never know that reference bandwidth is changed. You are getting one metric, they are getting one metric. So this will be a problem while calculating the SPF. Right? Now if I see, all my cost will be changed. For 2.2.2.2, my cost has become 101. For 23.0, it was 110. I remove this. Now again it is changed. Reverted back. 11 and 20. Right? So like this, if you are changing the reference bandwidth, but remember, if you are changing the reference bandwidth, should be changed on all other routers also. By changing the reference bandwidth, you can influence the cost. This setting is local to router, but this value should be changed on all the routers. And networks with links with higher speed or bandwidth will have the cost of 1. What is he speaking? If you are having a reference bandwidth of default value 100 Mbps and you are having interlinks who are all having gigs and 100 gigs of links, all those will be having the cost as 1 itself. Now our router cannot differentiate how between 100 gigs link and 1 gig link. Yeah. So in order to differentiate this, obviously you have to increase your reference bandwidth according to them. Okay. And in these networks, it is recommended to change reference bandwidth as per the OSPF. And if you want to set the bandwidth, you have to go, this is an interface level command, and change the bandwidth. And how do you change it? With the bandwidth, give the value. But changing the bandwidth is not recommended. Why? Because if you are changing this, it will be influencing many others, quality of service and other things also. So what is recommended to change the cost directly. IP OSPF cost value on the interface, and this method is more controllable but requires much work and management if the network is large and complex. And now to verify that, you can see show IP OSPF interface brief or show IP OSPF interface will show you what is a command, what is a value. Let me go on to this interface. Now my value to reach 2.2.2.2 is 11. Is 0 by 0. Here my cost is 10. Right? Now what will I do is I'll change my cost directly. How will I do it? Interface is 0 by 0. Cost 1265535. If I am giving it as 100, let it change effect. Here is what actually happened. It is going via serial 1 by 2. Why? Because the cost we have changed is 100. Earlier it was 11. Now I made it 100. Now according to router, if it goes through internet 0 by 0, value is 101. Right? But better than this serial interface, it is giving cost only 65. Right? Cost is 100. Let me give it as 40. And see here immediately our value have become 41 and it is via Ethernet 0 by 0. So like this, it will be a very good thing if you are changing the cost directly on the interface instead of going for bandwidth and changing the reference bandwidth. Clear? So changing the OSPF cost directly on the interface, it would be very controllable and it would be very easy. Clear? And how do you check it? Obviously, I have shown you this show IP interface, OSPF interface brief or show IP OSPF interface. See here. Interface My cost is 164. Brief. This will directly show you cost here, only the cost. And if you want to get in detail, show IP, OSPF interface, particular interface, this will also show you this. Only for that particular interface. Yeah. So this is how you can check the interface cost.